So we're simplifying expressions, and that goes back to our days of someone just like 10/12 and taking a fraction, being like, wow, we can divide them both by 2. Okay, so divide by 2, and we get 5/6. We've got ourselves a simplified fraction. Well, that's what we're going to be looking to do, but we're going to deal with more of our algebraic expressions. So we're going to hit the basics of our rules with our variables, and then we're going to start getting into the expression process of it. So let's hit some of the basics. So for example, if we've got x squared times x to the 6th power. So because we are multiplying, we're actually adding the exponents together. Well, where's that coming from? Well, x to the 2nd power is just x times x. X to the 6th power is x times x times x times x times x times x. So when we look at all of this that we have here, we've got 8 of them. So that's why it's x to the 8th power. All right. The other rule that we've got here is we've got an exponent raised to an exponent. So x to the 3rd power raised to the 2nd power. In this particular case, we do multiply, and we get x to the 6th power. Now, where's that coming from? Well, remember, an exponent means that we are doing repeat multiplication. So it's x to the 3rd times x to the 3rd. And then it's a lot like what we just had above. Well, we're multiplying, and I've got 3 of them on the left side. I got 3 of them on the right side. So altogether, it's x to the 6th power that we've got. All right, let's see who else we've got in here. Let's bring out our coefficients. All right, so we just got through with power to a power. So let's look at something like 3x to the 2nd power raised to the 3rd power. All right, we just got through saying power to a power and we multiply. Good. But exponents have different rules than just simply your plain numbers. And this 3 is a plain 3. It's not an exponent. It's 3x, and then it's to the 2nd power. So because it's a plain old number, it follows your plain old number rules. So what is 3 to the 3rd power? Well, 3 times 3 times 3, say hello to 27. And exponents. This is where I multiply. 2 times 3 is 6, so it's x to the 6th power. All right, and again, let's look at why that's the case. 3x squared means 3 times x squared times 3 times x squared times 3 times x squared. So this is where I can do my 3 times my 3 times my 3. There's my 27. X to the 2nd power, x to the 2nd power, x all multiplied. All right, we've got 6 of those x's there, so it's x to the 6th power. The last way you can look at it there is if you want to, make it into an exponent. 3 is the same as 3 to the 1st power. So if you multiply 3 times 2, x to the 6, 3 times 1 is your 3, but then we can actually do 3 to the 3rd power to get your 27. So it just kind of depends on how you want to look at it. You want to sneak that 1 in there and go ahead and multiply through? Go right ahead. If you just want to realize that your numbers get treated differently than your exponents, hey, that's fine as well. Just pick a lane and be consistent with it. All right, the other one that we want to look at here too is our division. And division is, well, it's the opposite of multiplication. So with multiplication, we were adding the exponents. With division, we're going to subtract those exponents. So something very basic here, if we have something like x to the 3rd power divided by x to the 2nd power, well, we subtract 3 minus 2, that's 1, it's just an x. What happens if we flip it around? Well, your thought process is actually going to be the same. Like, I don't get involved with, oh, it's a negative exponent, so it goes in the denominator. No, I view it as it's a division problem, so we're going to subtract. Just do the normal subtraction problem. Just bigger number first. So you're still doing 3 minus 2 in your head. But what you're asking yourself is, where are more of the x's at? Well, there are more in the denominator, so you need your x in the denominator. Remember, I need that 1 up there as a placeholder. I can't just leave it blank. That's up there. So we do want to watch for that. Now, bring in your coefficients. And again, they get treated differently than our exponents do. So if I have someone like 4x to the second, y to the 7th, divided by 6x to the 3rd, and then y to the 2nd power. Okay, numbers just get treated like numbers. The fraction 4, 6. Well, you can divide them both by 2, so you're going to get 2/3. Again, the numbers out in front get treated like normal numbers back from the days of middle school math. Now we can start playing with the exponents. Okay, I have x's, so I'm going to subtract. Oh, but more of them are in the denominator, so that's why there's an x down there. 3 minus 2 is 1. I've got 1x. The y's. 7 minus 2 is 5. Well, there were more of them upstairs, so that's why it's y to the 5th. And now we're done, and we have simplified. All right? So again, the big thing here is exponent rules are different than when you are dealing with just your constants or your plain old numbers like we saw here. All right? Yeah, that's it for today. Let's just hit the basics. We'll get in a little bit more in depth tomorrow.